Hello, this is Eyal. This is the Virtual Artificial Intelligence for Enterprise User Group. I hope you guys can see us. This is our first meetup, and we have a chat where you can ask questions in real time. Let me just say a couple of things before I start. My name is Eyal, and I've been passionate about AI for over 20 years now. I've been following with it, and I was very happy to see that the second winter of AI, what we call, was over a couple of years back, and AI became very prominent recently. And one thing that I do is I started a website which tries to get people to understand and get started with AI. So if you are new to AI, and particularly if you are Java developers, you are welcome to. I'll put it in the chat now. You're welcome to look at that website. Type it in. It's AI for Java. And this is geared particularly towards Java developers, as I feel that Java is a little bit deprived when it comes to artificial intelligence. So this is about me, and we also have Yolande. Yolande is from Oracle, and they help us make this group possible and reach out to different speakers. And the speaker for today is Daniel Takabayashi, who agreed to be our first speaker in that group. And he developed an open source platform that we would like to hear about. So I'm going to make him the presenter, and you're welcome to ask some questions while he's presenting or afterwards, whenever you find appropriate. So let's see. I think Daniel is on.
Yes.
So why don't you tell us a little bit about yourself and then start the presentation?
Sure. Well, hello everybody. My name is Daniel Takabayashi. I'm from Brazil, and I have been working as architect in many enterprise for 20 years. No, not 20, but 15 years. And right now I'm working as manager of machine learning things in B2W. And also I have found the little startup in Brazil called Boo Labs, and specializing in artificial intelligence, that was acquired by B2W about 3 years ago. And that's it. And now I am a software manager of this kind of products there. But also here I show you my contacts if anyone wants to send me some message or ask me about what I will talk today. But actually what I'm bringing to talk in this first talk was about this project called Marvin AI. Is a very new platform, just launched less than a year by B2W as open source initiative, try to help the process of deploying and managing machine learning models in production. So I will talk about some problems, and I will try to show why we decide to create this tool. And then I will talk to about the platform, giving some insights about the features that we created, and how we can use the platform. So my idea is try to only the hands-on. I don't know if it will be possible to do today. And another thing is I'm reusing this presentation from a talk that I gave a few months ago. So yeah. So talking about problems in machine learning, the first problem is the knowledge, the domains that we need to know to create this kind of project. So the whole idea here is try to show that to build, and always I will try to talk about practical problems, not just the theoretical ones, but actually as architect, sorry. I have a lot of problems because one of my responsibilities is try to archive the requirements, right? Not only the functional, but the quality requirements. And Marvin is more like this. So the problems that I bring was problems related with how to build, how to become true something that our company wants to put in production. So talking about this, I'm bringing this here I'm showing how many knowledge, different fields that someone or a team must know to bring the project to become true. So I'm talking about skills related with software engineer, scientific computer, not only the data science itself or only machine learning algorithms. Because when you want to put something in production, you have to to archive the non-quality, the quality requirements. And to do that, you need to know software engineer, as you need to do big data or ETL techniques to bring the data, and start telling as well to try to show what is your what you are doing and what will be your strategy to solve the problem using AI. So the thing here is about the team. To have all this knowledge in the same team is very expensive. So and to have all this knowledge in the same person is almost impossible, right? So this is the problem. We need a lot of different skills to try to build something that can go to production. And another problem is related with it's not a problem. Yes, it's a problem, but it's more the way that the thing is going in the AI world, and it's about the type of professionals that we have. So we have the type A, that means the analysis part of the data scientist. Is about this kind of professional, is that professional that comes from the, just for instance, comes from the academia, they come from the university, maybe they hold a master or a doctor, but they never worked before in real projects that went to production and that has a lot of users trying to using. And the type B is the type that is more building, is the guy that knows how to build the things, and maybe he comes from another world. I mean, not another world, sure, but he comes from the software engineer world. So maybe he's an architect or someone that comes from that is a very high experienced programmer, and he realized that the AI world is a good work to start, and he learned a lot to try, but he doesn't have the same knowledge, the same experience like with math or algorithms related with machine learning as the type A. But he can do the things, right? He can do the things. He can, even searching the internet or reading tutorials about machine learning or about algorithms, or even just trying to learn the libraries like scikit-learn, but he can build something. And this is the professional that I think the most companies want right now, because as I said, it's impossible to only with the knowledge related with algorithms in machine learning. It's almost impossible to put something in production. And what the almost people does is they build the algorithm, they build the model, and using, you know, like scikit-learn or something like the notebook, the IPython notebook, for instance. And then after they finish it, they just give for another guy or another team to rewrite all the code related with this. And this is a very expensive way to do, right? So this is why almost people or almost manager like to have the type B. And this is why the type B is almost like unicorns, because it's almost impossible to find this kind of people, because if you realize is a person that is a very experienced programmer, and after that he became a very experienced machine learning developer, or the opposite, but it's almost impossible. Another problem is related with the development life cycle or development cycle in this kind of project, that come from the phase that we need to get a data, we need to discover what is the data that is related with our problem, and after that we need to clean and prepare, do all kind of manipulations in the data to transform the data, right, in the format that we want, or in a format that is necessary to put inside the algorithm. And after that, we train the data, right? We train the algorithm to archive the model, and then we test. We test this model that was created in the phase before, and this is the most important thing. We check if the test was good, if the results was good, and if it's not, we need to start from the beginning again and again and again and again. So this is a cycle that must to be that is a cycle that we must to finish as fast as possible, because there is a lot of risks in this kind of project. And one of the risks is related with we don't know when we start this kind of project, a project related with machine learning, doesn't matter what, like prediction something, to try to prediction, I don't know, the prices of houses, or to prediction the behavior of your customer. We in the beginning of this project, is almost impossible to know if this possible is even real, if it's possible to finish, or if it's possible to get something that is good enough to go to production. So when we start this project, in the manager perspective, we don't know if we will archive the results that we want, that the requirements that the functional, you know, the business wants. So if we take too long to give something, to have some, you know, like some insight about if it's possible or not to archive the functional requirements, is almost impossible, or the risk become bigger and bigger, because someone can come and just finish or just stop with the project. So this is something very important. We need to pass for all this phase as fast as possible, to show for the people that is paying that is possible to, and I forgot the word, sorry guys, but that is possible to finish and to archive the requirement. So the baseline, the establishment of the baseline of the MVP is strategic to the success of the project. And another thing is about reproducibility. So we need to save the hypothesis. And right now, almost people are using notebooks to do this, but we need to save the data as well. And we need to save the code and the metrics related with each iteration of the project. And this is very important because just the hypothesis without the data is nothing, right? Because the data, and normal AI project, a regular AI project, is very sensitive to the data. So if the data change, the metrics will change. So we need to save. We need to have versions of each interaction or each result of the interaction that we have. Then we can go further or go back in the time and bring the different perspectives of the results, the different versions of the data. And the final problem that I bring is related with the scalability. So this is more is about the software can scale if I put in production. The almost data scientists that I know can't do this kind of thing, or is very painful for them to archive like thousands of requests per second or something like that. That is something that is very common in a big company, like, for instance, B2W, that has a lot of hundreds of thousands of clients. So any kind of solution in AI that goes to out must to support this kind of scalability. Sorry. So must to scale. Because it's not, we are not talking about a prototype or something like that, or an MVP. Is an MVP, but must go to production. So this is the problem. And as almost data science just use Jupyter notebooks to, as the interactive IDE to prototype it, this is a challenge as well, because it's almost impossible to archive this kind of scalability with these tools. So this is a problem. If the language as well, because almost people here, I think, is Java programmer, right? So we know about this. This is very usual for us, but for people that come from another world, come from the math world with Python or R, is a little different. It's more hard to archive this scalability. Sorry. So we had the simple the whole problem. This 5 problem that I just talked about, we had in B2W as well. B2W, I didn't talk about B2W, but because it's not the focus of us right now. But B2W is like an Amazon in Latin America. It's the biggest e-commerce and logistics company, and has almost 1/4 of the market. So it's a huge company. And we had the same problem there. We have the same 5 problems. And the thing that they asked us was how we could to simplify the process of exploring, build, testing, and deploy machine learning projects in a reproducible way. So this was the question: how we could do this. And one of the thoughts that we had was, what if we just abstract and standardize a lot of things, trying to abstract all complexity about the architecture that must be used, or some architecture that is compliance, that has the compliance with the scale or with the security and with a lot of others no quality requirements. So this was our thoughts. And what if we standardize it, the way that the people does the things, like how the people code, or how the people deploy, or how the people save and retrieve the artifacts related with the machine learning project. So think about this. We create the Marvin, right? The Marvin Platform. Marvin Platform is a platform that supports the development and the management of models, having focus to put in production. This is the important thing. So Marvin is not only for prototype things. Marvin is a platform that can help you simplifying the process of the whole machine learning project life cycle, from the beginning, from the exploration, when you just have a problem, when you just have questions and you need to answer, and you need to show that you have the answers, from the exploration to the deployment, when you have to put something in production and you have to give APIs to the other systems consume these predictions or this intelligence. So now I will talk about the Marvin. And Marvin was started at B2W in 2016 to solve internal problems. And but back in that time, we realized that the problem was very ambitious. So that was almost impossible to just, with few people, like 3 or 4 people, to bring this and in that good and in a quality way, with quality. Sorry. So we talked with our directors, and we asked if it was possible to transform this project in an open source project. It's because in Brazil, guys, this is a very important point. In Brazil, we don't have the biggest company. They don't have the practice to open the project. We are a little like with low profile. The almost big company has low profile, so they don't want to be they don't want to show what they are doing. We still have this kind of mindset. So, but this means that was a problem. This is why it's very important to put here. Was a problem at the beginning, but after that, after we show that maybe we could archive more successful with the project being open sourced, so we could transform them in open source and using the Apache 2 license. That is one of the most opened license in the open source community. And then we published it in PAPS, one conference that talks about AI for industry in Boston. The first paper related with Marvin. And actually the paper was about one of the design pattern that we invented with this product. And after that, we already released it more than 3 versions. We had a group, but it's still a localized group in Brazil. The community is growing and growing. And one of the most important things here is because Marvin is become an Apache project. So after working a lot and show the product and all the thoughts behind the project, and we could to start the incubation of this project. So right now he's being incubated by Apache, but we are just in the beginning. We are in that phase that we need to migrate all the code to the Apache servers, and we are rebranding as well, and that's it. So yeah, so now it's more an Apache project that a project that just one company take cares, right? So here's the page that we already have about the Marvin, and all the stats related with the migration process, right? So if you want to know more about this, you just have to type, I think, Apache Marvin AI incubator, and we will get the page, the same page. Okay, so now I will talk a little more about the things behind Marvin. And I think one of the most important things behind Marvin is about the DASFE design pattern. And what is DASFE? DASFE was a way that we found to simplify and standardize the process of create and managing a machine learning project, because we realized that all project, doesn't matter the complexity, but not all, but the majority of the project has the same, the same interaction, the data scientists, they do the same thing independently of the project. They always have to get a data, they always have to train, they have to prepare this data, because as we know, to bring this data, we need to transform maybe in to matrix this data. We need to change the representation, the vectorial space, to put inside the algorithms, the common algorithms. So here is about this: preparing the data, training the data, and the evaluation related with the model that was created. So what we did in Marvin was just separate these concerns in different models, and we give name of this to these models. And another thing that we did was we showed that was very important to have artifacts that have been saved or is saved in the final of each action. That here we call this phases of action. So we have the first action, data acquisition, cleaning; the second action, preparation, training preparation; the model training, and the model evaluation. And the model evaluation has the output of the model evaluation is the metrics. The output of the model training is the model itself, is a kind of serializable representation of the model in memory. And we have the initial data set. This means that when you go to your database to bring the data, you are bringing the whole data, right? So this is that we call initial data set, the real data. And after that, we can transform this data, then we have the data set itself. Okay, so here is the batch actions. The batch actions means, this flow means something that take too long to be finished, to be processed, and that has an output. And here we have the online actions. The firstly is the prediction feedback, when your problem needs or your solution has a feedback loop or something like that, bringing something from outside, like the impression of your customer or the behavior of the application that is consuming your predictions, to the inside to the process of training your model. So and here we have the prediction preparation, that because here the online action means something that you need to consume in a synchronized way. You ask, and you want an answer, like a prediction. So you send a message related with your scenario or your context, and you want a result. I mean, a result of your model, the prediction itself. So here, but before you do this, the message here is more or less will be a raw message, right? Will be the whole features related with an event, for instance. But you need to prepare this message before you send to the prediction. And this is the phase that you do this. You get the input message and you transform this message, and then we can run the model itself, the prediction method of the model itself. And this is DASFE. DASFE is a way to to standardize the thing, and this, believe it or not, can help the data scientists to organize the code and organize their minds as well. And this help a lot if you talk about architecture, because if you have this very separated, this concerns very separated, this concept very separated, we can deploy this separated. We can version each of this artifacts separated. So we can scale more. We can have a better quality in your CI/CD process. So we can have a lot of good things just for just because we separated the concepts. So this is one of the proofs about bringing the architecture mindset to the machine learning world. The machine learn to bring this to the machine learn industry as well. And just talk a little more about the main concepts inside Marvin. We have the engine. The engine is the code related with the solution of the problem. So it's the code that the data scientist will write, and is a kind of implementation of the DASFE pattern. Sorry. So, and the engine for Marvin doesn't matter if you are using Python or Scala or R. Doesn't matter, because we have some components here that can connect if your engine, and once you have followed the implementation, you follow the design pattern, we can connect and we can control all the behaviors of your engine and give them few characteristics. And another main component that we have is the artifacts. And the artifacts are binary, versioned binaries that we persist and represent the initial data set, the data set, the model, and the metrics as well. So with this, it's possible to retrieve a data set that I have created like week ago or a month ago or even a year ago, because all data set or binaries, they are saved in a remote or local data set, file data set like AWS S3 or yeah. And we have the engine executor as well. The engine executor is a kind of server, application server that brings all the abstraction related with the architecture and how to parallel, how to distribute, how to have version. And the engine executor is the guy that gives the REST APIs and gives the capability of to be available to the engine. So it's a component that is connected with the engine one by one, and is the is like is the main component, I think, about Marvin. When we are talking about architecture, is the main component for sure. And yeah, this is the component that is, it doesn't matter if you created your engine or code in Python or R, because engine executor can talk with the both language. And I will show how. I will show you the architecture behind all these things. And finally, we have the toolbox. The toolbox is a set of CLIs and utilities, class, and binary and libraries that is very specific per program language, and that supports the whole process of exploring, develop, test, and deploying your engine. So the toolbox right now, we have different binaries that must be installed to have the toolbox set. But one of the things that we are doing is just create just one, and yeah, to simplify the process. Instead of install one toolbox per language, you have just one for both, for all languages. And this is more or less like the components, they are related with each other. And here we have the toolbox where I can manage the engine, and the engine is the way that we are using to generate the artifacts. So, and here the engine is agnostic, is language agnostic, and brings the code of the user. In this case, the user is the programmer, the data scientist. And the toolbox also serves to manage the executor manager, the engine executor, sorry, the engine executor. So through the toolbox, we can deploy, we can scale, we can control the version of the things, and the relationship between the engine executor with the engine is the abstraction relationship. So the engine executor is the abstraction to the engine. So I will show this. That is very important to realize how Marvin works. This is the architecture view, the context diagram of the Marvin, and how Marvin can be used inside an enterprise. So yeah, so here is Marvin. Marvin represents and the idea behind Marvin is not to replace the apps, the application that we already have. The idea, the proposal of Marvin is just to bring the intelligence from inside this application to outside. And Marvin delivers a bunch of REST APIs to support the communication with, or the integration with, these applications, right? So let's pretend that we have the pricing system. So the price system here, but the intelligence to decide dynamically which price we need to apply is here inside Marvin. So in this case, we will have just one engine that has the intelligence, the AI, to dynamically decide the best price for our customer. And here we still have the price system, where we have a lot of screens, we have a lot of CRUDs, and we can control parameters on this kind of thing. So this is just an example how this can be, how the things works. And Marvin brings consoles, dashboards, data cert connectors, integration connectors, to make the life of the data scientist. So in this way, one example is about how to use the Spark itself. In Marvin is very easy because we just have to instantiate a class, and yes, you have the access for the Spark infrastructure, and you can use the Spark SQL cycle, to retrieve all data. So it's more or less how the thing works. Yeah. And this is a little more about how the Marvin engine executor and the engine talk each other. So Marvin was designed use the actor model. So the actor model is a model that brings the asynchronous model programming for each single component or each single concept inside the system. So the way that we design this is each component is a component that can live alone or can be installed alone in a different Docker or machine, doesn't matter. And even alone, even separated, they can talk each other without complexity, right? So this is why it's possible to scale Marvin, because we can put each of these little squares installed in a different and separated machine with a different profile. And the same happens with the Marvin engine as well, because if you are following the DASFE design pattern, so this means that your code is separated as well. Was well designed and is separated, and this means that we can just bring one piece of the whole solution and installed in a different machine, and give more availability status or scaling to support more requests per second, for instance. And this is the way. And how we do this? We do this using the gRPC protocol. There is a is a protocol that Google's brings for public, and it's a protocol that doesn't matter what is the language that the server side was written. The client side can be the same. So this is the magic behind the language agnostic capability that we have. We just have this gRPC server that can instrument the whole code that the data scientist has created. And we do this to, for example, to save and version the artifact in the end of the action. Like after we train the model, I can just, using this artifact manager, goes and save the memory state of this object. So this is more or less like Marvin works. And here we have the layer responsible by all the APIs. So with Marvin, we bring, I think, almost 38 different APIs, and each API can be used to build a whole flow, doesn't matter the complexity, a whole flow to control and manage all phases in the batch and in the online actions. So we can decide to bring the data, clean the data, but not transform the data. Or we can decide to test a lot of different hypotheses using the training action with a lot of different implementation of the different algorithms, but using the same data set, and decide which one after have the metrics, or after evaluate the metrics, we can decide if the first was better or the second was better, and every this whole flow can be automatically managed by Marvin, okay, using these APIs. So this is the I think is one of the most important thing here, because each thing, each start, each status check, health check, consumption has your own API. So this is in my opinion is amazing. And this is a little more is something that we are doing, that we are building, but with this transition from B2W to Apache, I don't know if we will continue, but here the perspective. This is another company that brings the cluster view to Marvin installation. So using this, it's possible to manage hundreds of nodes with different Marvin engines inside, and controlling the metadata, and controlling the status of each actor. So I can turn off just one actor if I want. So this is nice as well. This is more like the Cloudera Manager. I think is something similar with the Cloudera Manager, right? So is a admin dashboard with admin capabilities. And this is just an example of how the cluster admin can works inside a cluster of Marvin. So here is the engine executor, and as I said, one engine executor is managed just one engine. And we have the engine executor cluster. The idea behind the cluster of Marvin is the Marvin clusters is just manage the things related with administration concepts, like deploy, like turn off, stop, start, reload, this kind of thing. Is not a cluster to receive data. And this is what I'm trying to show here. This is the cluster admin that can admin a lot of nodes as groups, but the load balancer must be outside of the Marvin ecosystem. So the load balance is outside, and here is the client consuming the load balance to decide each node will send the message that we need. Okay, yeah, it's more or less, this is a draft, and as I said, we will change, maybe we will change some concepts once the project become Apache, and we will have a lot of other contributors and with different perspectives. So yeah, we need to wait a little more to see if this will happen or not. And that's it. So now I will just try to show very fastly, because we already maybe in 5 minutes, how Marvin works or looks like. Okay, so here I have my terminal. Okay, and Marvin, once Marvin is installed, he become a kind of utility, and this utility has a lot of commands. And the first, and I think the most important command, is the command that generates a new engine. Sorry. This is the command, engine generate. This is a kind of scaffold generate. While we are creating, we just have to give the name as, I don't know, Oh, okay, sorry. I will change my. Okay, just a minute, guys. Okay, now can you see? Okay, so we'll start from the beginning. So Marvin is this utility that once installed will give you the Marvin utility. The way that the installation is very easy. You just have to is a PyPy library, so you just have to type pip install, and if you come from the Python world, you know what I'm. You do yeah. If you come from the Python world, you know what I mean. But if you come from Java, is like the SBT. Pip is like the SBT, so you just have to install from there. Let me hide this. Sorry. So once we have, sorry guys, again I lost my. Okay. So once you have installed, you can type Marvin, and the first thing is generate the engine. Sorry. And this, they will ask you something, some few informations like the name, a short description, and one of the things that the Toolbox brings is a template of project, a template for your engine that already has the most usable libraries that a data scientist can have to start the exploration process, like scikit, like MATLAB, NumPy, pandas, this these libraries. So here he's installing, and now we will have Marvin will create another environment. In this case, I using Python, right? So this is another important thing. Right now, we are just supporting Python as the primary language to create the engines, but is in your backlog to start to. We just started to create the toolbox for air as well. So once you had, typed once Marvin had created the project, we need just to activate this project, and here we will have the scaffold related with the project that we created. And here, if you type Marvin again, you will have a bunch of commands that give you different perspective to interact with the project, like deploy the project, or even control the version of the project, or start the APIs and this kind of thing. So what I will do is just to show a few comments, because we don't have time to finish this, but I will show just a few things, like the environment, the development environment of Marvin. So we have this Marvin Notebook command that brings the IPython notebook inside Marvin. Is a bit, yeah, it's the same IPython notebook that we already know, but with few modifications. And yeah, I will share again, but I will share in this time. I will share my whole screen. So here we will start the notebook, but this notebook, this is important, comes with the engine. So it's a notebook that is a little different. And one of the things that is different here is this thing that bring the whole phases, the whole steps, the whole actions that we need to inform to Marvin. So the thing that this work is more or less like this: you need to mark a cell. You can write the code related, and you will mark a cell as exitor and cleaner phase. Then you mark, and this means that from now Marvin will use this code as the code related with the exitor and cleaner action. And this in this case is just this is not actually is not a code itself. It's just an import. But the thing is the integration between the Jupyter notebook and the Marvin engine as well. So this is very has a big value. So yeah, so this is one thing. So you can, as data scientist, you can use the Jupyter, the same thing, to write your code related with DASFE. Yeah, and once you do this, and once you finish, you can just you can just use another command called engine HTTP server to bring the REST APIs that will already connected with your code. Once you have a code, of course. Now I don't have a code here, but yeah. And once you started the server, you will have a 1000 port. You will have documentation related with the APIs. Yeah, so here we have from the exitor phase, all the APIs available, all the operation available, training preparator, trainer, evaluator, predictor, and so on. And using this, it's possible also to check if the things are working or not. So here is just the health check of the API, and here is the results. So once you already have created your code, you can just start the APIs to check if the message, if Marvin is working correctly, or you can just expose this port to a user or to another developer team that has the app, that is creating the app, that will use these APIs. Okay, and the final thing that I want to show is just the last command is about the dry run. The dry run command. The dry run is the command that can guarantee that what you did is okay to go to production. So this is a kind of test that will check if your code is a valid implementation of the DASFE pattern. So you just have to type, but I will give just a little more information here. So the Marvin dry run command, with the Marvin dry run command, you can choose which action you want to try. Okay, so or without parameter, the Marvin dry run will pass all the values, all the actions. So and he will give you a lot of informations, even about how long took your process. Then you can have insights about if the performance is good enough or not. Here, of course, is just one instance running because it's running locally, but we can use the same concept to test remotely. And yeah, I think that's it. I think for now, I talked a lot about Marvin, and I think the last message is about Marvin's become an Apache project, and as a Apache project, we need more contributors, right? So, and I think one good thing in our group is we can have people from the different words, from the software engineer world and from the AI world as well. And I mean, we can have the type A and the type A and the type B as well. And yeah, and Marvin is about the both things. We can, as contributor, you can give a new example of engine, or instead of work in the core of the project. Another thing is documentation. We need to create more documentations. Right now we have this book here, but we need to put more, informations, more, a lot of more things. And yeah, and we have another project called AutoML, Marvin AutoML, that is a very innovative project that brings the capability that a lot of cloud providers are selling us. When this is the component that can give the chance for a person that don't know nothing about AI to create an AI. So this is very nice, is very good for the whole community as well. And yeah, that's it. Okay, so that's it, guys. Thank you.
Okay, so this is me again. I hope you can see me. I guess not. Give me a second. Okay, we're back with your face. Oh, here I am. Thank you very much. That was very interesting. It's also a challenge for all of us to come and join you. Is there what's the best way to join your open source project? Would you like to share your contact, or is there just if we go on GitHub, if we find it there, or what would be the best way?
Yeah, I think the best way is go to the GitHub page. There we have the email of our group. We have a group in Google, and we have a Gitter account as well. And now we already have the incubator. I think one of the good thing as well is go to the Marvin Apache page. Right now we already have the mailing list about Marvin, and start from the issues right now, because we have some issues that are marked as like for initiators or for people that just want to collaborate but don't know nothing about, even because the executor was made using Scala, but we have something with Python and JavaScript as well in this new model called AutoML. So I think I think it's more like it's community more than like me. We have more people working in Marvin. So I think the first thing is try to connect, to clone, give us some stars, of course, and and start to collaborate. That's it.
Okay, I have a couple of questions that might be interesting for the rest of us. I think first thing I'm curious if what language this is written in.
Yes, Scala. I think Scala's the core thing was made with Scala. Yeah, if you have the toolbox, the toolbox is a little different. The toolbox was made because right now we have the one toolbox per language, but actually we just have the Python toolbox. So that was made using Python, and the executor component was made using Scala. And as I said, we are using the gRPC to connect the both words. And the idea is reuse the same thing to connect with the new toolboxes. Yeah. So, and we have, I think this is the two big components.
And another question that came up was if there are any other products or projects that you're aware of that do similar things or part of the things that Marvin does, and how does it compare to them?
Yes, I think one of the most similar project that I know is the prediction IO, I think, and is a project that Apache has incubated as well. And but the difference between is the one of the thing is the usability in the perspective of the data scientist, because predict, I think, from developers to developers. So, and in our perspective, we come from the architecture perspective, the developer perspective as well, but to data scientists. So I think the usability, how the thing works, if it's easy, the abstraction, we work a little better, actually, in my opinion, sure. But, and the language agnostic as well, this feature, prediction IO just delivers the Java and the Scala opportunity to use them. And yeah, I think the whole idea, because actually it was one of our papers that we launched, the DASFE idea comes from prediction IO. They had something similar called DAISY, and we just extended the DAISY idea. And this is why I think we decide to do and to implement something that is a little more simple, because we tried to use and was a little painful for us, even as developers. Imagine about the data scientists that never, without any experience with programmer, was very hard, actually. So I think this is one of the products is prediction IO. And with this new model, I think maybe the AutoML is the open source alternative to Google AutoML, to Amazon ML, all these things. Yeah.
Okay, let me see. If anybody has any more questions, please type them in the chat. Let me look if there is anything there. Okay, somebody is asking any main need in the toolbox, any language that you're looking for to create.
Sorry, can you repeat? Sorry.
I
I think R and Scala will be the next one. We are working with Cloudera as well, with some people of Cloudera, to try to bring the R language inside Marvin as well, and because they use a lot, and the main idea behind the help of Cloudera is try to, because Cloudera already has a product called Workbench, something like that, and they have templates inside this that when you start a new project, you can choose a template, and the idea is try to give the opportunity for the users to use Marvin as a template as well inside this tool. And this is why we are working together. They are contributors in our project as well, and that's it. So I think will be the next one. And after that, for sure, Scala and Java.
I'm not sure I got the language. It sounded
Air. Yes, Erlang.
Okay. Like this. I'm sorry. My accent. So that's
No, mine is worst. Don't worry.
the language of the data scientists. Okay. I don't see any more questions, so I'd like to thank Daniel.
Thank you. Thank you.
I'm going
Okay. Nice.
So next month we are working on the next meeting, and we hope to have a talk about federated learning, which will be learning at the UI, or learning at the endpoints, rather than the learning that we have now, which is usually done on a server. So that sounds pretty interesting. And let me just repeat what I said in the beginning. I'll put it in the chat here, if I can. Here it is. If anybody is interested, and if you're especially if you're Java people and you want to get started with AI and do it the Java way, here is a link that I put in the chat in YouTube that you can try it out. I'd like any kind of feedback about that, and of course any kind of feedback about this user group, what we've done today, because it's the first time. We need all the feedback we can get about the time that we did it, the day, the format, my accent, anything that you think can be updated, improved, or anything else that you have in mind. Please, we will welcome any feedback. We'll be grateful to hear. Thanks again to Oracle for helping us out, and that is it for today. We will see you next month. Thank you very much. Bye-bye.